I know we're all super duper excited. Oh.
I am super duper excited.
You should be super duper excited. It's pretty awesome.
In Spanish, all of the calculus students were talking about how they got like B's on their tests or something, and how horrible their grade is.
Yeah, I know.
Me too.
And then you go to my honors pre-calc and over half of them got a D or an F. You know, it feels great.
Well, we're good. Are we doing better than that?
Well, what we do in here is significantly easier than what we do in there. But yes, you guys are doing awesome for the most part.
Not really. I have an 80.
I have an 86. Don't even.
Oh, not
I have a 79.
84. That's lower than you.
Oh,
I
I
did.
Okay,
thought you said 94.
No.
My feet are peeling.
Someone took
That's
like 20
disgusting.
miles from my
okay, can we go ahead and get started? This will literally take 2 minutes. That's awesome.
Really?
Okay, so for logarithmic inverses, just like any other inverse, an inverse undoes whatever the original function is. So if I'm talking about a normal function, y equals x cubed, if I were trying to find the inverse for this, the first thing we do is we switch our x and our y, and then we solve for y. So how would I get y by itself in this one?
Square root it by 3.
Cube root it. That's called cube rooting. So when I do that, I get y to the negative 1, because that's what inverse is, equals the cube root of x. This is interesting because if I plug in cube root of x for x, it's going to undo the cube that's happening there. So that's the whole point of an inverse. Just like normal functions, our logarithmic functions also have inverses. In fact, they have very specific inverses for them. So when I'm talking about a log inverse,
Zach's already won.
Not bad. Something good enough.
Why'd you get y minus 1?
that's what we call an inverse, y negative 1. It's not y to the negative 1 power, it's just y negative 1. Okay, so if I have y equals 10 to the x, its inverse is log of x. So if I have log to the 10, those two are going to cancel each other out. For example, if I have log to the 10 to the, I don't know, x power, the log and the 10 are inverses, so they cancel each other out, which means the answer is just whatever that exponent was.
Wait, so 10 is equal to log.
So 10 and log are inverses of each other.
Oh.
Because they cancel each other out.
Log R.
So the answer is just x.
So the answer would just be whatever the power I'm taking x is.
So log
Is it-
is 10.
Log is automatic.
Log base, okay.
10.
Log is automatically base 10, yes.
Oh, okay.
Yeah.
Okay, that's how I came.
So if I had, I don't know, log to the 10 of, or to the 4th power, the log and the 10 cancel each other out, and the answer is just 4.
That's why the base.
So anytime you have log 10, it's going to go away. The same thing applies if I have an e, because e is the inverse to natural log. So if I have y equals e to the x as my original function, its inverse function is natural log of x. Hi.
What?
Yay. Okay, join in.
Good God. It's so dark in here.
The same thing would happen then if I were to do natural log of e.
Wait, is that L?
Yes, I always do the curly for natural log L. So if I have natural log of e to the x, the natural log and the e are inverses, so they cancel each other out, which means my answer is just whatever I'm taking e to the power of. Just like log and 10 are inverses of each other. Why are you looking at it like that?
So it's just x again.
So it's just x again, or 4, or 2, whatever the exponent is that I'm raising to, or e to.
So the L and the E are separate.
The ln and the e are separate, yes.
Alright, is there gonna be like an E and an L on the test?
You never know. So log and 10
how
are
do you know?
inverses.
How do you know if it's
Natural log and e are inverses. Natural log is ln. Normal
How
log
do you
is
know?
L
Is
O
it,
G.
if it's E?
What do you mean?
Is it always natural log if it's E?
The inverse of E is always natural log, yes.
So no other letter, just E.
Correct. E is a very finite, it's a very specific base. There's a reason that we use it. Okay, so inverses, natural log and E are inverses of each other. 10 and log are inverses of each other. Did you get it, Zach? I bet he's not.
Yeah, a little bit.
He did. Okay, just checking.
Zach, I'm so proud of you.
So that is, as I said, this would take 2 minutes. That's it. I was just showing you the inverses for logarithmic functions.
That's because it's gonna be on the review.
What year? It's actually not on the review.
It's gonna be on.
Well, we
Because
have a
there's really
review.
no questions that I can use it for other than if I gave you natural log times e to the 15, what's the answer?
15.
15, because natural log and e cancel each other out. Same thing if I gave you log to the 10th of a. What's my answer?
A.
A, because log and 10 are inverses and they cancel each other out. That is the most I could do with that for you.
That's
You
it.
should,
That's
that's
it.
the whole test.
No. Okay, so on Canvas, you do have a review. It has exponential problems where you have to simplify. It has logarithmic problems where you have to use the expansion and condensing properties. And then there's geometric series and sequence on there as well. This is due tomorrow. Before you take the quiz, you may work with a partner or a group. Zach, if Kennedy or Jonah want to join, I could put you in a breakout group. Not Jonah, because he has to leave early.
Yes. Sure, go.